Hey, Oscar, can you hear me? Okay.
Yeah,
Okay, all right, so let's get started with the interview. You hear me well?
sure. Everything's great.
Okay, so I was looking your resume. One of the things that really hit me is your first intern at Facebook. Can you can you explain it to me? Like, what did you work it on? What was the most challenging problem? Overall, just let me know how was your experience there, please.
Okay. Well, my first internship at Facebook was during 2018. I work at the Menlo Park office, that's the central office from the company, and I work in a team called Messenger Search. Uh, just on a simple terms, Messenger Search was the team that was responsible for every search on all the surfaces across Messenger. That means across iOS, Android, and web. In my case, I was working on web, and we were developing a feature called Universal Message Search. And the idea was simple. Before my internship, when you were on web and you were searching something, for example, potato, you will see all the chats that were named potato or all your contacts that were named potato. After my internship, you were able to find if inside some of those threads you mentioned the word potato. I show you a result where you can click it and go directly to that thread and directly to that message. So for example, if that message was 3 weeks ago, you can go directly to that message. That was my biggest contribution overall.
Okay, great. Was it launched to general audience? I mean, to the public? Or
Yeah,
what
it is
stage
live
did
right now.
you?
I mean, the backend
Okay,
services was almost fully developed. I just have a little bit. My main job was just creating the UI to support that new feature.
okay, sounds great. What about your second experience? Was it did you work on the same? How it changed it? What do you think
Uh, it, it,
was
a
different?
lot difficult. In the first one, I think that the biggest challenge that I was faced was the amount of code that Facebook has. Facebook has a lot of code related to frontend, like thousands of React components, and those components are really variable in code quality. Some of them were written in 2015. Some of them were written 1 year ago. Some of them were written 10 years ago. And the ability to know and
Oh,
understand a library so well so you can see the changes in 10 years and being able to implement something that worked all over the place, that was really challenging. In this new second internship, I think that the biggest challenge is that I'm working on something completely different. I'm working on things more related to backend and to machine learning. And those two things are things that really interest me, but they are not things that I have like super great experience with. So I have to start learning a lot of things during my internship.
okay. Yeah, learning is part of this industry. So you are in the right path.
Thank you.
Okay, Oscar. So how comfortable do you feel with uh, technical problems? Because we are going to jump into a technical problem.
I completely agree. Let's start with the fun part.
Okay, great. So we have. I am gonna paste a little example from the
Yeah.
problem. Let's say we have this string, right?
Yeah.
String S. This string has a length of 6.
Yeah.
What I want you to do is, well, you can skip this step, or if you think so, if you think it's the right way. But I want you to compress the string and then tell me what is the new length of the string. By compressing, I mean if you have a repeated character like this one, like A, and then V, what you can do is just write a number right after our letter, So we can have only the letter and the number, and our string is compressed. That is just a simple way to compress a string. So in this example, we have the A 2 times, so we can write A 2 times, and then we have the V 3 times. So we can just write V and 3. And as our C is only 1 time, we don't really need to write anything after the C, because it will add another character and wouldn't be compressing anything at all, right?
Okay.
So what I want you to tell me is, given this string, only tell me what is the new length of the compressed string. All right? Does it make sense for you?
Okay. I'm just going to re-explain the problem so we know that we're talking about the same thing. We have a string. That string is of what? It's just lowercase English letters. It's just any character on the ASCII. It is encoded in UTF-8 or UTF-16 or something like that. It could be digits. It could be just numbers.
Okay, now for the for making the compressing algorithm work, we will have only English lowercase letters.
English lowercase letters. That simplifies a lot of problems.
Yeah.
Thank you. English lowercase. Okay. English lowercase. So we have this string of just English lowercase. No underscores, no spaces, nothing else. Just English lowercase.
Oh, no special characters. Okay. Only English lowercase.
So the idea is to compress it. And to compress it is, you tell me which letter you were talking about, and then a number. Then the next letter, and then a number. For example, I am going to put some test cases. So what happens if we have something like this? This string. 2 A's, 2 B's, 1 A. What the compression should be A 2 times, B 3 times, and then an A? Or it should be
that's right.
A 4 times. Okay. So the first one.
The first one.
Okay. So the order does matter. Okay.
So the length of the new string will be 5 as well.
Yeah, in this case, it will be 5. Let me see another challenging. What happens if we have this thing? Yeah, something like this. In this case, will be A, B, C, D, and E 2 times, right?
Yeah, that's right.
And the length will be 6. Okay.
And in this case, yeah, the length doesn't change.
It's not a super great compressed algorithm, but it's something to start with. Okay. Now I'm going to start thinking about possible solutions. The simpler solution that I think I could create is just follow your idea, like exactly the way that you explain it in code. You give me a string, and then I recreate this compressed string. And after I recreate that compressed string, I just get the size of that string, and that's what I return. That is a good idea. I think just because of the
what
way
is the complexity?
Sorry?
Did you ask me if that is a good idea?
That could be a good idea. I think that this idea could be improved just because at the end we want just a number. We don't need this compressed string. And I think that by creating it, we are doing more work that is needed. And the idea on computing is always do the least amount of work.
Yeah, you're right. Completely.
Okay. So
I am gonna write the function.
Okay.
So you don't have to create it again. This is the function. Feel free to write the code inside the function. If you need any other function or structure, just let me know or write it as a global one.
Okay. So the next idea that I am thinking about It's more or less the original idea. I mean, in comments, the original idea will be to create the compressed string. And then the next part will be just to get the size. That's it.
Okay.
How, well, what will be the complexity of doing that? What will be the complexity of creating that compressed string? Suppose that the original string has n characters. N characters. So in that sense, to create a compressed string, what would be the worst possible input for this problem? For example, an A, B, C, D, just all the letters in the alphabet, copy pasted a lot of times. At the end, the new compressed string will be exactly of the same size. So the compressed
Yeah, the
string will be
compressed string can be, yeah.
at worst in terms of size. In terms of size, in terms of time, sorry, and in terms of memory, we will need to create this memory. Yeah, I forgot how to write. In case of memory, we'll need to create that compressed string. Just by the way of the compressed algorithm, and in this test case, I show you that the, or in this one, the size could be the same. I'm thinking it is possible that the size will be bigger. Let me think about it. It is possible that the size will be bigger. I think not, but it's possible that the size will be exactly the same. So in the worst case, we'll be just creating a new string of n characters. So I will be using open memory plus like another row of n string. That is the original idea. I think I'm not able to improve on the time of the solution because at least I have to read every character in the string. But I think I might be able to give you the result, the result of this function without creating the compressed string. If I am able to
Okay.
do that, I will be saving a lot of memory because probably the string could be humongous. So how I am going to be able to solve this problem without creating the compressed string? And my idea is something like this. We have a string like this one. So let's just have a variable called size or total or result. I'm going to start thinking about the name trigger. So I'm just reading the first character. Oh, it's an 8. Let me read the second character. Oh, it's an 8 too. Let me read the third character. Okay, it's a B. It's not the same character. I read A 2 times. So that means I have to, in the case I'm going to create the compressed string, have to write 8 and the number 2. But that is not information that I need. I just need how many characters that information will be stored in the string. The A is just a character. That's 1. And the 2, I just need to get how many digits does that number have. And that's it. That's the second idea that I have. Go to the string and add to total uh, plus 1. 1 because I'm adding a character, A, B, C, C, W, whatever character, and the number of digits that I have seen that character. Like times, something like that. In that case, I am able to traverse the string, the original string, without creating a new one and return you just the answer. What do you think about that second idea?
That's a good approach. So this approach you are not using uh, linear memory, right? You're
Okay,
just
just
traversing the string.
a couple of variables, constant memory. That's a lot better.
Okay, so the memory is gonna be constant. Okay.
Mm-hmm.
Yeah, that sounds good. So let's jump into coding.
This is the next important part. How I'm able to translate that information into code. Just because of code style, I'm just going to do this in auto and say that I'm going to return an int. Because of the idea of how my algorithm works, this string could be const. So string. Let's just call this data to be a little bit more expressive. So we have a string.
Okay.
I need just a reference to it, and I'm not going to change anything for that original string. So that could be const. The next thing is the result. In a way, the length after compressed. Let's just shorten like this. This needs to be an integer, and this integer needs to be as at least as big as the string. And the size of the string in C++ is just of size 10. This could be just an int if we. Oh, I'm not able to edit this anymore. The connection just broke.
Okay.
Hello, can you still hear me? That is something that usually happens.
Yeah.
Let me reload the window. Technical
Worries,
problems.
just try to connect again.
Technical problems are something that happens to all of us, and I think that at least 50% of all my interviews has had this problem. So let's just wait a couple of seconds.
Yeah, no worries. No worries. Just try to. Yeah.
You see that it's connected, and I am writing. Can you hear? Can you see the changes I am doing right now? Just writing random things.
No. No, I can see anything. Check out if you have the same URL we had
Let me
at the
open it
beginning.
again.
Also, you can try to turn off the camera.
Okay, let's see what happens.
No worries.
Nothing?
No, I am not able to see. Check that you have the same URL we sent you.
Yeah, I already did that. Let me see what other things could I be.
Because sometimes this tool forks code as soon as you start to editing. So double check if you have the same URL. If not, I already sent you
a new link or something like that. Someone, please.
Okay. As you were explaining me, length. You're not going to use any extra memory. You're just going to do everything in place.
Yeah,
that's fine. We are.
One quick question in in the meanwhile. This function you wrote it as if it returns an int. Is it okay that I can assume that the size of the string will fit on it?
Yeah, no worries. Yeah. As long as we can cast the result as an integer, that's fine.
Okay. Still not able to edit anything.
Okay, it's the last link that I sent you.
Okay. Both of them open the same one. Nothing?
Nothing yet.
What we can do? Drop in an incognito mode just to see if that is on the link. Open this.
Okay, I am already seeing. However, in the stream, there are no changes at all. So Manuel, can you
to open the.
Could you assist here?
I'm trying to open the link in another browser or in an incognito tab or something like that. So I confirm. Yeah, finally, I think that I'm able to see something. Yeah? Please tell me that you're seeing something.
Hold on a little bit because I think people can see in the streaming.
Okay, I will wait.
It happens all the time, so don't worry.
It is working now.
Is working now?
Okay.
Yes, thank you. Okay, so let's go back to the idea. I don't know where. Okay. So I'm going to use an auxiliary function, something like digit number of digits. So I can send a number, for example, 10, and get back 2 as the number of digits that the number has. Or I can send a 9 and just get back 1. Because I'm going to use that too. So after that, let's just use char as the current character. And this is equal to data in position 0. And before here, I have a problem. What happens if I get back an empty string? That is possible? That is a valid input?
No, you will have at least one character.
Okay, so if I have at least one, then this thing is okay. And let's just call this int. It is the number of times occurrence. And let's just start with 1. And then just do a for loop. Also a equal to 1, or I will be equal to data size plus I. Yeah, that's it. So if the data in that position is exactly the same as the current character, in that sense, I just need to add 1 to the current times. If that is not the case, then is where the fun begins. Because I have to add 1 because of the character and the number of digits that the number of times I have seen this thing.
Okay.
I have the information then. In that case, I can just set this back to 1 and the current character equal to data in position I. And after that, it's as simple as just return line after that. And that's it. I think that was my original approach. Let's just see if there is a problem with this code. I start with a size of 0. What happens if there is only one character? Like it's only like that. The compressed string will be A1. No, just A, right? So it's original.
Yeah.
No. And the compressed version. In that case, this will be 0, this will be the letter A, this will be a number 1, and I will never enter here. Because oh, and that problem also happening, for example, there is 2 A's. The last letter will not be counted in this code. So let's see a way to fix that. And that is as simple as doing something like this. Return plus 1 plus number of digits. Yeah, okay. This new solution has also a problem. Because if there is just one character, or even if there is a lot of characters, when I just see one character, the compressed string in my mind will be A1, and that is not the case. I just need the A. So there is two approach over here. In one way is to this function to return 0 whenever I get an input of 1, or to handle that case inside this function. Just to make this function clear, I'm just going to handle that case inside here. That's okay?
Yeah, that's fine.
This is going to be a little bit weird, but I hope that you follow along with me. Number of digits in compress. This is going to be a lambda, that just means a function that takes an integer, let's just call it x. And the only thing that it does is if x is equal to 1, return 0. We are not going to use anything. In our case, return number of digits of x. That's it. And this can be const because I'm never going to change it. And after I have this, I can replace it here. And this function will return 0 if the input is 1. In our case, it will just return the number of digits. And that's it. I don't know how much time we have left.
Okay, that's fine. That's fine. So let's move into questions for me. What kind of questions do you have for me?
Okay, so I have a couple of questions. So you feel free to answer all of them if you want to. If there is something that you don't want to talk about, that's completely fine for me.
Okay, yeah.
So the first thing that I would want to tell you is, what do you think is a good thing about the work, like about the company that you're working on? What is something that really excites you? And what are the things that you think that the company is being behind, or something that do you want to see an improvement on?
Okay, what I really like about the company and overall my work is I am able to work in challenging problems. So when you're able to work in such challenging problems, then you can learn a lot from those problems. You can also work with algorithms like this. Not most of the time, but sometimes you get stuck with a problem and realize that you have to create something like this, or a design pattern, a new technique. I mean, it's really challenging, interesting.
Yeah.
Well, one of the drawbacks of working here, as you mentioned, is the huge code base. So when you have such a huge code base, you have to learn how to navigate in such code base, and sometimes it's not as easy as it seems. But I mean, as you ramp up, then it gets easier, and as you start to write your own code, then it gets easier and easier. That's
Well,
pretty much
you
that. You're also able to work with. Okay.
And that it is it. Close.
Okay, Oscar. Thank you so much.
Thank you. Bye.